These next problems have to deal with compound inequalities. Okay, so compound inequalities means that we have more than one statement for each. Now, these have the word and it has the word or. Okay, the word and means that it's possible to have a number that makes both of these true at the same time. If you have the word or, that means that either one is true or the other one is true, but we can't have both of them true at the same time. So we want to solve this one and graph it and put it in interval notation. Well, it's already solved because we have x is less than or equal to 7 and x is greater than or equal to 4. Now, what I'm going to do is I'm actually going to graph all these separately and then put them together onto one so you can see more visually what's actually happening. All right, so first thing we'll do is put a 7 on here, and that's x. I'll just do the first one. X is less than or equal to 7, so it's a closed circle. The arrow is going to go to the right. Now, the other one is I have -4, so I'll put -4 down here. That's going to be an open circle, and this is going to go to the right because we said it's greater than, so it goes that way. Now, we want to combine both of these together into one. So if we smash these together, what's going to happen is you're going to get -4 and 7 will be on here, open circle at -4 and a closed circle at 7. And then what's going to happen is you look for where these graphs overlap. All right, so it's going to be in between these two. This is going to go that way forever. That goes that way forever. If you smash them together, combine them, then the arrows get cut off at each of these endpoints because this is going that way, but it's going to have to stop at the open circle. And this one's going that way, but it's going to have to stop at the closed circle here. So that would be what the final solution set looks like, would be this last one that I did here. Now you just want to write that with interval notation. Well, it'll be open circle with a 4, and then 7 is going to have a bracket. Okay, and that would be the answer on that one. So the final answer you'll have is just this last number line graph and then the interval notation. This next one, we need to solve each of these first. So 6x plus 1 less than or equal to 7. We're going to subtract 1 from both sides. You get 6x is less than or equal to 6. Now you want to get rid of the 6 in front of the x. It's multiplication, so you undo it by division, and we get x is less than or equal to 1. But then we want to do the same thing with this other one, 3x minus 7 greater than or equal to 11. We wanted to first add 7 to both sides, so we get 3x is greater than or equal to 18. Divide both sides by 3. We get x is greater than or equal to 6. But now we have to graph this. Let's graph each of these individually so you can see what the difference is there. I'm first going to start with x is less than or equal to 1. So here's 1. I'm going to do a closed circle. Less than means arrow goes to the left. Let's do the next one. Next one is a 6. That's going to be a closed circle. So both of these have closed circles, and the arrow goes to the right. If I put these together on one number line, you don't have anything that overlaps. One arrow goes to the left, starting from 1, and the other one goes to the right. So you're actually going to have 2 separate arrows on this one. One that's less than 1, and the other one that's greater than or equal to 6. So that's going to go to the right. Okay, so now I have both of these on the same graph. Because there's 2 different arrows, this time you're going to do 2 different intervals. Now, when you do the intervals on this, we'll do 1 for each. So I have -infinity to 1, and 1's going to have a bracket on it. And we're going to do a union. Okay, the union is the symbol for or. So that's why we use a U on this. That's going to go from 6, that's going to have a bracket, to infinity. So that's your answer there. You're going to have both of them. -infinity to 1 with a bracket, and then union 6 to infinity. Now we have one more that we'll do here. Again, these we have to first start off by solving. So for this one, we need to subtract 7x from both sides, and we'll get negative 5x is greater than negative 35. Then divide both sides by negative 5, remembering that whenever you divide an inequality by negative, the sign switches. So you get x is less than 7 for that one. Now for the other one, we have 5x is greater than 3x plus 8. We're going to subtract 3x from both sides. And we get 2x is greater than 8. But then we have to divide both sides. The sign does not flip here because we're not dividing by a negative. So I have x is less than 7. X is greater than 4. Now, notice that this problem has the word and in it. If you see the word and, you're only going to have one interval. This is one where these both can be combined together into one on the same graph. So this, let's first start by doing x is less than 7. So that would be right here with an open circle. And that would go to the left. Then if you want to graph greater than 4, you just put a 4 open circle, and that's going to go this direction. As you see here, there is some overlap on this problem. And so we'll just graph the overlap. It's going to be, we have 4 here, and it's going to go to 7. And there's going to be, everything is going to be shaded in between. So you're greater than 4, but at the same time, also less than 7. So all the numbers in the shaded region would make both these statements true at the same time. If you write this as an interval notation, you're just going to do a 4 and a 7, both as parentheses, because you have open circles on each end. So even though the arrows go in both directions, this is going to the left, but it's going to stop at the 4 when you combine both of these together. And then this arrow going to the right will be stopped at the 7. So that way your answer is only going to be between 4 and 7. Any numbers in there will make both of these statements true at the same time.